Nearly 4 miles beneath the Pacific, across the abyssal plains of the Clarion-Clipperton Zone, dark nodules lie loose on the sediment. They contain manganese, nickel, copper, and cobalt, materials tied to batteries, grids, industry, and national power. The wider nodule fields sit roughly 3,500 to 6,500 meters below sea level, in areas beyond national jurisdiction. Washington is accelerating a route for American companies to apply for access. Yet the strategic contradiction begins before a collector touches the bottom. The rocks are at sea. The commercial-scale chain that could turn them into usable products is not built on American soil. That changes the real question. This is not simply whether the United States can recover minerals from extreme depth. It is whether a domestic license can become internationally recognized access, reliable ocean machinery, financeable production, permitted processing, and commodity-specific refining. Permission, resources, and industrial power are different things. A government can accelerate the first without creating the other two. The numbers make the opportunity look enormous. The U.S. Geological Survey gives a conservative estimate of 21.1 billion dry tons of nodules across the Clarion-Clipperton Zone. But that is a regional resource estimate, not a reserve, a market value, or proof that a particular patch can be mined economically. A map can show geological possibility. It cannot certify a factory, a customer, or a profit. The United States is not a party to the Law of the Sea Convention. For American companies, NOAA administers a domestic system under the Deep Seabed Hard Mineral Resources Act. An exploration license can cover surveys, research, and test mining. A commercial recovery permit is a separate authorization for material recovered for marketing or commercial purposes. Those stages sound adjacent. Legally and industrially, they are not interchangeable. In January 2026, NOAA created an optional consolidated application process. An applicant can submit exploration and commercial recovery material together, and NOAA estimated that the new procedure could save about 100 days. The executive branch had directed the agency to expedite reviews under existing law. But consolidation did not erase the separate instruments, and an estimated administrative saving was never a promise that a permit would be issued. The distinction became visible in TMC USA's case. The company reported 2 exploration applications covering 187,017 square kilometers and an initial commercial recovery application covering 25,160. A later consolidated application covered about 65,000 square kilometers and cited an estimated 619 million wet tons of resources. In April 2026, NOAA found that filing in full compliance. TMC itself stated that this was procedural, not approval, grant, or issuance of either authorization. After compliance comes certification, interagency consultation, environmental review, public participation, and a final NOAA decision with possible conditions. As of NOAA's July update, the agency listed 5 current exploration applications and 2 older active exploration licenses issued in 1984. It listed no existing commercial recovery permit. The door is moving faster. No American commercial mine has walked through it. Beyond the shoreline, a second system governs the same ocean in the eyes of most governments. The International Seabed Authority says it is the internationally recognized authority for mineral activity in the area for parties to the convention. It argues that attempts to operate outside its framework can create legal, diplomatic, economic, security, financial, and reputational risks. The American position relies on domestic law and a claimed high seas freedom. This documentary cannot settle that legal dispute. Markets still have to price it. Recognition risk becomes practical when a ship needs a flag, a cargo needs insurance, a project needs lenders, and processed material needs buyers. Congressional researchers reported that TMC USA's NOAA application areas overlap portions of areas already held under ISA contracts through Nauru and Tonga-sponsored affiliates. By December 2025, 40 countries had announced opposition to deep seabed mining. A NOAA permit could therefore be valid in the American system while still leaving counterparties to judge exposure elsewhere. The international route is not a finished alternative. In June 2026, the ISA reported 31 exploration contracts and no approved commercial operation. In July, its council was still working through a third revision of draft exploitation rules and unresolved questions involving environmental thresholds, payments, inspections, monitoring, test mining, closure, compliance, and enforcement. The contest is not between one complete rulebook and one shortcut. It is between two incomplete paths carrying different forms of uncertainty. The engineering evidence is more substantial than a paper concept. During a 2022 integrated test, a prototype collector measuring 6 by 12 meters traveled about 80 kilometers and brought up roughly 3,000 tons of nodules. That demonstrated collection at meaningful test scale. It was still test mining, not commercial recovery. The proposed production system is designed for a different order of magnitude: 3 million wet tons per year. Commissioning and production are expressly conditional on an NOAA commercial recovery permit. Scaling from thousands of tons in a test to millions each year means proving uptime, riser reliability, vessel coordination, maintenance, transfer at sea, port handling, and continuous support in one connected system. Each link must operate at the rate required by the next, because stored nodules do not solve a bottleneck in transport or processing. A machine can work once, while an industrial network still fails to work every day. That scale gap also changes capital risk. The project must spend before it knows whether each legal, environmental, and operating condition will align. Meanwhile, the IEA reported that critical mineral investment fell 9% in 2025, while battery metal capital spending fell by more than 20%. A faster application can reduce waiting. It cannot make capital cheap, remove commodity cycles, or guarantee that investors will fund the required offshore and onshore build-out. When a nodule reaches a deck, the strategic work has barely started. TMC's stated chain first separates a manganese silicate product and a combined nickel-copper-cobalt matte. Nickel, cobalt, and copper then require further refining into separate products. Rare earth extraction is described only as a possible later expansion. A cargo of nodules is therefore not a cargo of battery-grade metals, and it is not evidence of American rare earth independence. There has been real process development. TMC reported pilot primary processing in the United States and Canada, industrial-scale primary processing at PAMCO in Japan, and matte refining tests at SGS in Canada. That evidence pushes back against the idea that the chemistry is imaginary. It does not establish a permitted, financed, commissioned American plant. The company's technical report also said there was no binding commercial agreement for PAMCO processing and that the Japanese pathway was forward-looking and contingent. Brownsville, Texas shows the distance between a pathway and capacity. TMC announced a strategic partnership and an exclusive negotiation right involving 1,466 acres at the port. In its filing, the company reported no current financial commitment for that land option. It also reported that it lacked the environmental and other permits required for commercial-scale onshore nodule processing and refining. The potential site matters. So does the fact that it remains potential. Even a completed plant would enter a highly concentrated system. The IEA says that, excluding rare earths, the average share controlled by the leading refining country rose from 70% in 2023 to 72% in 2025. China accounts for more than 90% of manganese refining, while Indonesia leads nickel refining. Virtually all 2023 to 2025 growth in refined manganese and nickel supply came from the dominant supplier. The choke point is not one country or one mineral. It is specialized capability distributed unevenly across commodities. None of this means the seabed holds only speculative geology. A company pre-feasibility study for the defined NORI-D project declared 51 million wet tons of probable mineral reserves. It estimated an after-tax net present value of $5.5 billion and an internal rate of return of 27%. Those figures are model outputs under stated assumptions, not realized returns. But the reserve classification is a genuine project-specific counterweight to claims that every nodule number is merely hypothetical. Scope is the safeguard. 51 million wet tons in one project cannot convert 21.1 billion dry tons across a region into reserves. Nor can the estimated 619 million wet tons cited for a broader application be treated as recoverable output. Resource, reserve, recovered material, and refined product belong to different stages. Mixing them produces a spectacular number and a false industrial conclusion. Demand is conditional too. IEA scenarios indicate that cobalt demand growth has moderated as lithium iron phosphate batteries expanded, and that early-stage nickel projects could cover projected demand if they are actually delivered. At the same time, refining remains concentrated, and some projected commodity gaps persist. Seabed nodules may diversify supply. They are not a guaranteed answer to one inevitable universal shortage. The deepest uncertainty is not an excuse for certainty in either direction. NOAA identifies habitat destruction, sediment disturbance, plumes, noise, light, food web change, and water quality effects as plausible impact pathways. It also says the scale and significance of many effects remain incompletely determined. Only 26% of the global seafloor had been mapped to modern standards in the agency's review, and very little deep habitat had been characterized in detail. Field evidence reveals persistence and partial recovery at the same time. Researchers revisiting a 1979 collector test found physical tracks still visible 44 years later. Some measured ecological parameters showed recovery. Others showed persistent effects. Recovery of a parameter was not restoration of the ecosystem, and the continuing track was not proof that every biological function remained equally damaged. A separate collector component test found suspended particle concentrations 50 meters from collection lanes, reaching as much as 4 orders of magnitude above ambient. Concentrations then fell rapidly with distance, time, and height. Most of the plumes stayed near the bottom. A gravity current traveled 500 meters downslope, while detectable sediment dispersion extended through a 4.5-kilometer monitoring area. The result constrains both stories. Neither harmless dust nor a measured basin-wide catastrophe. Commercial operations would run at a different intensity and duration. Component tests cannot directly establish cumulative ecosystem effects over years or decades. A monitored test can define what happened under its own geometry. It cannot supply a universal impact radius for an industry that does not yet operate commercially. That uncertainty affects more than an environmental argument. It can alter monitoring requirements, operating conditions, liability, financing, schedules, and public acceptance. The environment is not a final box checked after engineering. It is one of the variables that determines whether the system can become commercial at all. Now return to the opening image. Dark rocks resting 4 miles down. Their depth makes the project look like a story about conquering the ocean. Yet lifting them may be only the most visible link. A commercial chain must pass through competing legal regimes, scale a test into a reliable fleet, finance years of construction, measure uncertain impacts, and turn mixed mineral feedstock into products that customers can use. If NOAA issues a commercial recovery permit, that would resolve one critical condition. It would not automatically settle international recognition, deliver a binding processing contract, permit Brownsville, stabilize metal prices, or prove long-duration environmental performance. If those other pieces align, seabed nodules could become a new source of supply. If they do not, faster licensing may produce authorized access without durable industrial power. The strategic contest, then, is not won at the moment a collector reaches the bottom. It is won only if the material can travel through an accepted, monitored, financeable chain all the way to refined products. America may find minerals 4 miles beneath the Pacific. The decisive depth is the distance between permission and production, and a decisive part of that distance is on land.